So lesson 12, writing a linear equation in slope-intercept form. Can I get a volunteer to read Let's Explore the Idea? And number 2, please. Giselle.
Follow the directions to write the equation of a line through the origin. Fill in the blanks as you go.
Hugo?
Learn on this page that the slope between any 2 points on a non-vertical line is the same. Let m equals slope and xy equals any point on the line. Fill in the blanks to show how to find the slope of a line using 0, 0 and x1.
Okay, so I need you to highlight where it says let m equal the slope. We know that the variable we use for slope is always going to be m. And we know that this point x comma y is going to be any point on the line. I'm not telling you which specific point, it's just a general statement as any point. Okay? It's similar when they tell you you can get dessert. Are they telling you you need to get cheesecake, pie, chocolate cake, tres leches? No, they're telling you get dessert overall. So in this case, the point x comma y, it's any point on the line. All right, now what we're going to be doing is we're going to be labeling the points. So let's start by labeling the first part. And the first point is going to be which one? Which is the first point? Marcus.
X is the first point?
Now, let's pay attention to the back part right here. We have this point and we have this point. So we have 2 points, right? Can somebody tell me which one is my first point? Marilyn. Sandejas. Okay, so my first point is 0, 0. So I want to label that x1 and y1. What is my second point? Renicia. Okay, so if my second point is xy, I'm going to label that x2, y2. And I'm going to make a quick note on the top right. Remember that the slope formula is m equals y2 minus y1 divided by x2 minus x1. Jimena, can you tell me what my x1 is? Okay. Christopher, can you tell me what my y2 is? X1 is 0. What will be my y2? Look on the board. It's giving you a hint. Giving you a hint. Y. Okay. Remember, these are connected. 0 is x1. 0 is y1. X is x2. And y is y2. That's why we put the labels at the bottom. Now, if we're going to finish our equation, we have m equals y minus what number goes there in the blank? Jocelyn. Okay, and make sure that you answer in a complete sentence, please. Now, going back to my formula, we have x2 minus x1. What is my x2? What number goes there? What variable goes there? Marcus.
The variable that goes there is x.
Okay, so we have x minus 0. Okay, now can I get somebody to read number 3 for us? Straightforward, easy. Edgar. So we're going to simplify the equation. What does that mean? What do we need to do there, Muley?
We need to fill in the empty spaces with y and x.
Exactly. So we don't need to write the zeros because they're useless. Similar as if I tell you that you have $20 minus 0. Does it matter that you have a 0 there? No. Right, can I get a volunteer to read 4 for us, please? And make sure that it's loud and clear. Eduardo.
What is the next step in writing the equation if you want to isolate y on one side?
Okay, so now let's highlight what this one is telling us to do. We're trying to figure out what is the next step to isolate the variable. And the variable that we're going to isolate is y. Can somebody tell me what does that mean? What does isolate the variable means? Kevin.
Leave it alone.
We're trying to leave y by itself. We're trying to leave it alone. How can I accomplish that? What do I need to do to be able to do that? Renicia. I need to do the inverse function. Perfect. Now, I'm going to write what we have on step 3, right here on step 4. So I need to write my y and the x. So if I have y divided by x and I'm trying to leave y by itself, what is the step that I need to take? What do I need to do? Mule.
Put the x next to the m.
Okay, so what is the proper term for that? We have a box that is empty. I agree with you. I know what you're trying to say. But what are we going to be doing to both sides, Mule? We're going to be doing the inverse operation. And Renicia, could you add a little bit more to it?
We're going to multiply both sides by x.
Okay, so we're going to be multiplying both sides by x because that is an inverse operation of dividing by x. So we're going to write it right here on the box. Now, we can actually cross this 2 out. We don't need this 2. Because you know that x divided by x gives you?
0.
Ooh. 1 divided by 1? 2 divided by 2? 1. 4 divided by 4?
1.
X divided by x? 1. Everything divided by itself is 1. Remember, when you're dividing, you're saying, how many times can this fit into this? So if I tell you, how many Daniels fit in Daniel? 1, right? How many classrooms fit in this classroom? 1. That's it. So when we're talking about something divided by itself, or someone divided by itself, it'll be always 1. Right? So now, we need to write that down, and we're going to put multiply both sides by x. Okay, show me with your hands. How do you feel so far? Now, the next step, it tells you to simplify. So what we're going to do is we are not going to write the x's anymore on the right side. So we're only going to write mx equals y. Volunteer to read 6. Mia.
Rewrite the equation with y on the left side.
Okay, so now We only need to switch it. Does that change our answer? No. Doesn't change your answer because it's similar as you saying that 2 bags of chips are worth $3, or you can get with $3 you can get 2 bags of chips. Same thing. The order doesn't matter. Here to read number 7 for us. Juan.
How do you know that the graph on the previous page represents a proportional relationship?
Okay, so first of all, you need to keep in mind that we're talking about a graph in the previous page. Okay, the graph that this one is referring is this graph that is on the right. I cut an image so we don't have to go back and look at it. How can we tell that this is a proportional relationship, Renicia?
We can tell that this is a proportional relationship because it has the same unit rate.
Okay, so you can tell that it has the same unit rate because of the triangles, remember? Yeah. Similar to what we did on the sub video. Now, what is the next thing that we need to know? Evelyn. That is a straight line. That is correct. It is a straight line, and that is one of the conditions. And what is the third condition? Eduardo? It goes through the origin. So you need to have those 3 things, and we're going to write those things down. So we write, it is proportional because it goes through the origin. And it has a constant unit rate. Okay. You're looking at the wrong image. So, explain the reasoning used in problems 2 through 6 to find a general equation for all proportional relationship. So, the graph of all proportional relationship is a line that goes through the origin, and the slope between any 2 points on the line is the same. So you can use x, y to represent any point on the line. Then you can use the point 0, 0 and x, y with the slope formula to find the slope m. And that gives you the equation y equals mx. All right, so now we're going to be solving this part as a group. Can I get a volunteer to read number 9 for us? Victor.
What is the slope of the line in this diagram? What is the y-intercept?
Okay, so we need to find the slope. So let's highlight slope. And we also need to find the y-intercept. So let's do it in order. To find the slope, how can we find the slope? What do we need to do? Hugo. Okay, so I'm going to use the slope formula. So I'm going to make a little note on the side. And I'm going to choose any 2 points. So the point that I'm going to choose is this point right here, which is 0, 1. And then I'm going to choose my next point, 2 and 5. So again, the 2 points that I'm choosing is 0, 1. And that point is point A. And the second point that I'm choosing is point D, which is 2, 5. So now that we have that, we are going to use the slope formula. M equals, can somebody tell me what that will be? Jocelyn.
5 minus 1 over 2 minus 0.
5 minus 1 over 2 minus 0. Aaron, what is 5 minus 1?
4.
And what is 4 divided by 2?
2.
So your slope is going to be 2. So let's write that down. Slope equals 2. Mia, what is the y-intercept?
The y-intercept is 1.
Okay, exactly. We have the point right here, A, that intercepts at 1. So we're going to put the y-intercept is at it's at 1.
Compare the slope and y-intercept of the diagram with the one in the introduction. How are they similar? How are they different?
The question is, where did I get the point 0, 1 and 2, 5? Mia, can you explain it for us? So we have the point 0 right here on my x value, and at 0, my graph is at 1. So that's where you get the point 0, 1. The next point is at 2 and 5. So that's how you get 2, 5. Yes, x, y. So now, in both diagrams, the slope of the line is 2. The only difference is that the y-intercept in this one is 1, not 0. So we're going to write that the slope is the same. But the y-intercept is at 1. For the next part, we're going to label every single point. So our first point A is going to be at, as we mentioned, 0, 1. B is going to be at 4, 9. C is going to be at 4, 1. D is going to be at 2, 5. And E is going to be at 2, 1. Now, part 12, it tells you to compare the coordinates to the ones in the diagram in the introduction. What do you notice? If you go back and we pay attention to the graph in the introduction has been attached on the right side. As you can tell, the intercept is 1 higher, and then point E is also 1 higher, and point C is also 1 higher. So you can see that the x coordinates stay the same because you have 0, 0, 2, 2, 4, 4, but your y coordinates went up 1. So that's why you're going to be writing that the x coordinates are the same, but the y coordinates went up by 1. And now, let's pay attention to question number 13. Renicia, read 13 for us, please.
How do you know that the graph on this page represents a linear function that is not a proportional relationship?
Sendejas.
It has a constant unit rate, but it doesn't go through the origin.
Now, you guys will be trying it another way. This will be for you to do independently, problem 14 and problem 15.